After having so much story or theory, let us solve some numerical problems. So this is example 8.2. A plain electromagnetic wave of frequency 25 megahertz travel in free space along x direction. So wave is traveling in x direction, and what is the frequency? Frequency is 25 megahertz. This is megahertz. At a particular point in space and time, E is equal to 6.3 joule volt per meter. What is B at this point? So we have to tell what is B at this point. Sorry, this is not joule, this is direction J. This is unit vector J, not joule. Now we have to solve what is the value of B. So we have already seen what is the magnitude of B. B is simply E by C. So if we know what is E at that point, we can measure what is B. So E is 6.3 volt per meter, and this is in Z direction. E is equal to 3 into C is equal to 3 into 10 to power 8 meter per second. So when we calculate, we get this 2.1 into 10 to power minus 8 Tesla. Now we have to find the direction. To find the direction, we note that E is along y direction. So E is along y direction, and the wave propagates along x axis. So x axis is occupied, y axis is occupied, only z axis is remaining. Therefore B should be in the direction perpendicular to both x and y. Using the vector algebra, E cross B should be along x direction, since j plus j and plus k is equal to I. B is along the z direction. Thus B is equal to 2.1 into 10 to power minus 8 k Tesla. So in this way we can find what is the magnetic field and what is its direction. So what we can say, E cross B must be in x direction. So if we cross this E and B, so we must propagate in x direction. So E is in plus j direction, and this B must be in plus z direction. Only then we get this propagation in x direction, because E cross B they will give a direction of x. So hence we can say this magnetic field is in z direction, and this magnetic field is 2.18 into 10 to power minus a. This k is unit vector into Tesla. So direction is z direction, and 2.1 into 10 to power 8 Tesla, that is the magnitude of this magnetic field. Next numerical 8.3. The magnetic field in a plane electromagnetic wave is given by By is equal to 2 into 10 to power minus 7 Tesla sine 0.5 into 10 to power 3x plus 1.5 into 10 to power 11 t. So this is the equation. So this is the equation for the magnetic field. Now few things we have to tell. What is the wavelength and frequency of the wave? So we have to tell. Write the expression for the electric field. So two things we have to tell. Now this is the equation that has been given to us. Now we compare this with standard equation. Standard equation is By is equal to B0 sine 2 pi x by t, and this is t by t. How do we write this equation? Because we have our equation B is equal to B0 or B0 sine kx minus omega t. So this was our equation. And we know k is nothing but 2 pi by lambda. So this 2 pi comes out common, and this is x by lambda. Now omega t, omega is equal to 2 pi by t. Again 2 pi comes out common, and we get t by t. Here they have used plus sign. Here they are using the plus sign, positive sign. So when we compare this with this standard equation, so what we get? Let us compare. So lambda is equal to 2 pi upon 0.5 into 10 to power 3 meter. How do we get this term? Here So here we have 0.5 into 10 to power 3 x, and this must be equal to 2 pi x by lambda. This must be equal to 2 pi x by lambda. So x and x cancelled out. So lambda is equal to nothing, 2 pi upon 0.5 into 10 to power 3. When we solve this thing, so what we get? 1.26 meter. So this is our wavelength, 1.26 centimeter. Sorry, centimeter, not meter, centimeter. Now what is the time period? Let us compare this. So 2 pi t by t. 2 pi t by t is equal to this quantity, is equal to 1.5 into 10 to power 11 t. T and t cancels out. So what we get? T is equal to, time period is equal to 2 pi by 1.5 into 10 to power 11. So when we calculate this number, so we get time period, but we want frequency. We want frequency. Frequency is nothing but 1 by t. So let us inverse this. So 1.5 into 10 to power 11 upon 2 pi. So this is our frequency. So frequency is 1.5 into 10 to power 11 upon 2 pi. So when we solve, we get 23.9 gigahertz. So that means 23.9 into 10 to power 9 hertz, because giga is 10 to power 9. So this is our frequency. So now we have calculated both the wavelength and frequency. Now now we have to write the expression for electric field, because magnetic field we already have. Electric field is E0 is equal to B0 C. Because we have this, B is equal to E by C, as we have seen in the previous example. So we have multiplied E is equal to BC, E0 is equal to BC. Now let us put the value. This B0 is, this is the B0, this is B0. So when we compare, B0 is 2 into 10 to power minus 7 Tesla. C is 3 into 10 to power 8 meter per second. Let us multiply. 3 into 2 is 6, minus 7 in plus 8 is plus 1 volt per meter. Electric field is in voltmeter. So this is our E0, 60 volt per meter. This is our E0. The electric field component is perpendicular to the direction of propagation and the direction of the magnetic field. Therefore, the electric field component along the z-axis is obtained as. So we have seen this magnetic field was in B direction, wave was traveling in x direction. So we have this electric field in z direction, because y is occupied by this magnetic field, wave is traveling in x. So then electric field must be in z direction. So what is the equation? This was 60. So Ez is equal to E0, which is 60 sine, and this thing is same, 0.5 into 10 to power 3x plus 1.5 into 10 to power 11 t volt per meter. So this is our electric field. This electric field is in z direction, and this is time varying electric field. This example 8.4, light with an energy flux of 18 watt per centimeter square. What is flux? Flux means how much energy per unit time. So energy per unit time per unit area, that is called flux. That is called flux. So energy per unit time is watt and area is meter square. So that's why unit is watt per meter square. Here it is given in centimeter square per centimeter. So we have to calculate accordingly. Falls on a non-reflecting surface at normal incidence. If the surface has an area of 20 centimeter square, find the average force exerted on the surface during 30-minute time span. So now we have to tell how much force was exerted. Now let us solve. The total energy falling on this surface, so we have this per centimeter square. So total energy is 18 watt per centimeter square. Now first we have to calculate what this is for only on 1 centimeter square. First we have to multiply with area. So area is 20 centimeter square, and centimeter square get cancelled. Now they are talking about 30 minute. So this is in watt, that means this is per second. Now we have to convert it into 30 minutes. So 30 minute is equal to 30 into 60, that means 1800 seconds. So we have to multiply with time 1800 seconds. When we calculate all these things, what we get? We get 6.48 into 10 to power 5 joule. So this is the total energy. This is the total energy that has fell on this surface. Now momentum delivered for complete absorption, P is equal to U by C. This is momentum. So total energy 6.48 into 10 to power 5 joule divided by velocity of light, and what we get? We get 2.16 into 10 to power minus 3 kilogram meter per second. This is the unit of momentum, kilogram meter per second, because momentum P is equal to mv. M is in kilogram, velocity in meter per second. So this is momentum. Now the average force exerted on surface. So what is the force? Force is simply change in momentum per unit time. So we have already have the momentum. Momentum is 2.16 into 10 to power minus 3, and what is time? Time is 1800 seconds. So we have already seen that 1800 seconds they have written in this form, 0.18 into 10 to power 4. So same thing they have written in this way. So what we get? After calculation of this number, we get 1.2 into 10 to power minus 6. This is minus 6 Newton. So force is very less. How will your result be modified if the surface is a perfect reflector? So think about this, how the result will be modified.